All right. So, try to think what changed since the last time I streamed because I streamed on Wednesday and then didn't stream on Friday. Oh yeah. Okay, so what I got done on Friday was in Python. I was able to get a really solid version of cropping done. So now I've got Python code with OpenCV where I fed it a bunch of different images, a bunch of different scenarios of books. Books being held in odd positions where like one, obviously like if you're reading page two, sometimes page one will be almost vertical. And spent a bunch of time debugging that as well. But I got it to a point where it can create bounding boxes automatically for those two pages of the book, and it like doesn't mess up, right? Like it's actually pretty reliable. And so I have a bunch of code now where I can feed it an image and it'll spit back the bounding box info for page one and page two. And it's pretty fast. Under, I think it was like, actually I got it down to like 2 seconds, but that was with a high res image. And then when I tested it with images coming off of the VR headset, it was like a quarter of a second. So now I need to translate that over to C++. So let's get into it. Let me see here. So I already know what this is going to be. Let's go with was it shift insert? Yeah, okay. OpenCV was already running in a GD extension, so I got that there. That works. In fact, we already have it where we can feed it multiple images and it'll merge them. So now the question is, well, I mean, I do have a question of like, do I even need that? I think I will. I think I will still need to merge multiple images together. But I think that this step, if I do this step first before merging those images, it may improve the quality of the merge. It might. If nothing else, it'll boost the speed. So once we've cropped down to like one page of text in the image, we're now talking about like a quarter of the image size. So if nothing else, everything should be 4 times faster. Everything I've been doing up until now. But then also because there's less to do, it's probably even faster than that because there's less like extra work. Like I have to imagine like it's not a straight linear like O of n type problem when you feed it an image and it has to do some work. There's probably when it's trying to like cluster things and figure out whether or not this group of pixels over here is connected to that group of pixels over there. It's probably like O of n plus something, or probably not O of n squared. I wouldn't expect that. Either way, it's if we're dealing with a quarter of the image, we're probably not dealing with a 4x speed bump. It's probably a 5 or 6, if I had to guess. All right, so we're going to do image text cropping, OpenCV text cropping in Godot. Let's just call it in Godot. Fine. And then what are we trying to do here? So I already had an AI attempt to translate the Python version to C++. So pull in C++ code. Test and confirm. Still works. And then integrate with image merging. So let's check that. And then debug extension crashing. I think that got resolved. Can get quality image. I think we were. So the can get quality image, that was before when we were doing the image merging. So I think we were getting better images. It's just a question of how many do you need? Do you need 3, 5, 7 images? Like how many is enough? And then how far away are the frames, right? Do you try to go for frames that are literally adjacent to each other? Or do you wait 2/100ths of a second and get a frame, get a series of frames that are, 5 frames over 1 second, right? Do you spread them out a bit? So I don't fully know the answer of what's better there tuning wise. All I observed was that quality went up, so at least that is a lever we can pull to improve things. Implement cropping. Well, we've done that. Now we're just pulling it in. And then implement dewarp and deskew. May or may not do that today. If we bring in the C++ code and it works, and when we integrate it with image merging, if the quality's decent, and then we pass it to Tesseract, if the OCRing is above like 90%, just on that alone, I'm not confident it will be. I think we will need dewarp and deskew, but it might. And if it is above 90%, then we're done. I'm not gonna waste time doing dewarp and deskew. I've done some research on it. I've seen some techniques with OpenCV for how to do it. And I will implement that sooner or later, but I'm kind of tired of C++ for the moment. I'm kind of tired of OpenCV. I'd like to get back to just Godot. Like, I'd like to get to some 3D modeling, and I'd like to get to some audio and actually start making this a real experience. So yeah, I'd rather not do the dewarp and deskew, but if it's necessary, we'll do it. So that'll be, and then actually, like, maybe for this list of things, I should always end with a question. And that question is largely an open-ended question to myself of, are we like ready? Let's just do like done with C++ for now? Question mark. I'd like to be done with it, right? I want this thing to be a complete experience. So as long as this is good enough, and as long as I feel like I've got levers to pull to make it better, I'm willing to put it aside and say that problem is a solved problem or a solvable problem. And then let's pivot back to what is needed for this to be like an alpha release product that I could put out there on the App Store for the MetaQuest. And for that means some 3D modeling. That means some like soundscape stuff. That means creating maybe like a menu with settings or like a launch icon, right? Like it's like those other things needed to make this a useful thing. Also, in theory, if all this is working today, then I could start testing this myself, like use myself as a guinea pig, of course. And I've thought about doing live streams on maybe big screen VR of me reading books using the app. So combination of testing the app, right? But also create a fun little book club and live stream myself in VR, reading a book in VR. Yeah, I wonder. It would be nice to get to that point where the app is actually functional and it's just a question of quality. How do I boost the quality? All right, so let me tie up some knots here and let's get to coding. Take a sip of water. So what have I got? Here is where I asked an AI to take the code that I had and convert it to C++. Right. So this is saying the bind methods. Let me check to make sure I've got code committed. I don't want to accidentally mess things up. We've got some bin files, git diff. Okay, we just changed the buffer size down to 3 to make it fast, make it go brr. And then change this down from like oh, do I have that wrong? No, that's probably right. Yeah. Either way, I tried to go down to like 30 hertz for the wait time, so that we don't get frames. So we don't. Ideally, we would get adjacent. This would get either adjacent frames or maybe like frames that are 2 apart at most. All right, I don't care about any of that. Git diff source. And then what is this? Middle index, odd, even, split. Okay, this is handling. Gotcha. Right, remind myself again what this was. Right, using the middle frame. Okay, so let's do git add source. That's the C++ source. Git add star.gd. Yeah, gd, not dbd. gd. All right, what do we got? That's the only things I want to commit right now. Git commit -m. Use middle frame as template for merging. So I think this is the last thing I did on Wednesday. And I should have pushed it on Wednesday, and I just didn't. Yeah, so that's basically, so I'm always going to provide, I think I'm always going to provide an odd number of frames to merge. And so if we provide 7, right, well then frame number 4, the one in the right dab middle, that should be the one that we use as the one we care about. And then the ones on either side of it, the 3 below it and the 3 above it, those we're trying to merge to that one. And that should make it easier on the code to like better align things for when we merge multiple images to improve the quality. All right. So let's get back to code. Now we're ready to go. So this is camera enhancer. We have a new method. I think I'll probably chuck it at the bottom. Let's go with bind methods. I'm trying to, my Vim is showing. What did I do there? What broke? Okay, fine. Here we go, bind methods. Enhance text from frames. Cool. And this is all starting to get a little unruly, so I'm gonna start trying to organize this at least a little bit. And we will call this, what is this? The find B boxes for text in image. Not what I wanted. Cool. Default value is 2. I don't want that. Again, my Vim commands, I'm trying to like do Vim. Okay, class DB, bind method, detect bounding boxes. Right. I'll mess with the method signature later because the AI is always, they always want to add extra features to your code that I really don't want. So this is the final method of it. Okay. Right, so there's all this code. Copy that. I'm sure there's a plugin for VS Code to support Vim commands. Huh, I thought there would have been... Oh, I guess not. Okay, so for whatever reason I thought there was like, it was like a class type thing. But no, there's like a class here. And then it's just methods. So I should be able to just come down here and let's do and let's again we'll do fine 775, huh? Okay. So down on 775, where is it at? Here we are. Make it very easy, so that way I don't accidentally confuse these things. So what are you complaining about? Has no member, right. So now we got to do the .h file changes. And here are those .h's. So I'm gonna go grab this as well. And I shouldn't need that. First, add these to your header file. That's right, so we've got the private methods. And I will grab that line as well. And then public method. And you know, these are all now together. I ended up dumping a bunch of these here. Yeah, we've got like this one, which isn't needed at all. Like, I gotta go clean all this up. I'll get there. Yeah, and then these getters and setters, which I don't care about. Like, I don't think I'm gonna set these things on the fly. I'll leave them for now, but all right, let me just put this up here. And let me grab that line again. Cool. So now we have detect text bounding boxes is a thing. The code's happy. Where is our build? Let's build it and see what happens. Now, I did ask it for some example GD script code for implementing just because I'm lazy. I mean, I could figure it out myself. So it's saying to call it, yeah, we've got our enhancer, you've got your image, it's saying load an image, I don't really care. And then just get the bounding box info. Cool. So where in Godot am I going to do this? So here's the merge multiple images. I actually like this, so let's go with old for that one. And let's just give this one the proper name. And it's going to hate me because now we've got duplicate methods. That's fine. You're old. Old and will likely get deleted at some point. So, capture high quality image. So we've done that. Merge multiple frames. So we get our frames. We're grabbing 3 of them in this case. And then we start a thread. I'll probably eventually do all this within the thread. Like, why bother? Like, why wouldn't we just... And even when like this is called, be like, just start a thread. I mean, maybe this signal, I think this is a signal. When this signal gets triggered for us to capture high quality image, that we probably just start a thread immediately so that this happens in the background. Not that it's that task intensive, but probably want that delayed. Or not delayed, rather, done in parallel. Okay, so then we call enhanced text bind. We have an array of images. And then we call it enhanced text here. I don't like the method names. This is kind of an ugly place to do. I mean, there's a lot of ugly things in this code that I need to refactor. For the moment, let's put it here. And we know we've got frame buffer. Well, it's 3 long, right? So the first one. Terrible use of this because Who knows how long that array is, but that's Windows. This is Android. There's no static typing. Yeah, so this is going to return, what is it? Detect text bounding boxes. Detect text bounding boxes at the bottom here, right? Right, so we're going to get an array. It's an array of dictionaries. I think it's an array of dictionaries. And that's going to tell us the bounding boxes. All right. By the way, real quick, where is this called from again? It's from the debug HUD, right? Yeah, right there. So basically the detector's toggle, I punched that button above my head to trigger this, just temporarily. Eventually this will all be automated. It'll just run all the time. Ooh, okay, so we grab a still image and we display it on the viewport, just so we can debug see roughly what we probably captured. We then save some versions of that to a folder so that we can visually check things out later. And then we just say, hey, go capture a high quality image. And then when it's done, we call high quality ready. And then we save that. And then we call OCR. This is process image. I should probably rename this because this is basically call OCR. And it took an image as a path, as an argument. Okay, I'll refactor this entire flow at some point. Let's just first get it working. Also, I was using this as an ugly excuse to save files off. So I had this like Boolean call OCR and just like using it as an excuse to write step number. Gross. Okay. Oops. Yeah, and then this is where we have a bunch of them down here, right? Gotcha. Okay. So I can call it whenever I want. Fine, why not? So var template image. That's a type image, and we'll make that frame buffer 1. And then let's steal that. And so basically we write that out. This is enhanced text, which is bound to here. Yeah, so we don't call that till lower. That's 0. Let's call this step 10. We'll call this step 0, as it was down here. Okay, so we get the bounding boxes. I may put a breakpoint here. you know, our AI friend should have given us decent code, at least somewhat functional code. Okay, so it's saying if we've got bounding boxes, go loop through them. I don't care. Let's just go get the 0th one. We should get the 0th box. Okay, and then it's saying the image with the box, pass it into this function. Oh, by the way, go save it off. Well, I already did the saving, so I don't care about that. This is a dictionary. Okay, yeah, so it is an array of dictionaries. And it's saying that we've got center X, center Y, angle. Why is there angle? I didn't ask you to handle angle. Rotation not handled in this simple example. Then why include it? But there is an angle. Ugh. I hate when AIs like do more work than they need to. Min area rect. Okay, so maybe it's just there already. Min area rect probably returns angle. Yeah, I mean, on the face of it, it's tempting to say, well, hey, why not keep it, right? If it's there. The thing is, if you're not going to use something, there's always a chance there's a bug there, or especially if you're working with multiple members of a team, somebody else will come along and they'll think that this is being used. So they'll look at this like, oh, we must be using it somewhere. I shouldn't mess with it. Or, hey, there's a bug on this line. This line's failing. I need to fix it. Meanwhile, you go downstream and you find out that like it's never used anywhere. But you end up fixing bugs in your code because this line is throwing an error on something that is never used in practice. So oftentimes it's better to just Yagni. You ain't gonna need it. If you don't need it, rip it out. Like why keep it? Keep the code as simple as it needs to be. No more complicated than it needs to be. What's the old one of the masters? I don't think it was Michelangelo. Might have been Leonardo. Like whichever one was a sculptor who would chip away at stone to create beautiful works of art. Said that like I begin by taking and I keep chipping away until there's nothing left to remove. So you keep taking things away until you've distilled something down to its perfection. I think I just put it. I saw like a hilarious, it was like AI train tracks that I saw the other day, which really spoke to me. Where was it? Ah, here we go. This has kind of been my experience. Only there was an AI version of this one. Yeah, it was basically like code written by an experienced software engineer. And I don't even think it was this image. I think there was like 2 or 3 tracks, right? And like one of them interchanges. And so, there's some architectural complexity, but it was like, this is what a seasoned, software engineer puts together. And this is what AI put together. And when you vibe code it was like, this is the vibe coded version. And it's like, yes, this version may work, but the extra complexity, sooner or later, the bill will come due and it'll hurt. All right, so this is taking center X, center Y, width, height, and then it's adding padding, which, sure, I wanted that. Clamp to image boundaries. Okay, fine. Create the cropped image. Image.create. Image.getFormat. Okay. Alternative method if you want to handle rotation. No, I didn't want to handle rotation. Don't give me that. Example usage with error handling. Okay, like I didn't need that either. Key points, yeah, fine. So all I need is this one simple method. And I'll dump it down here at the bottom. I'll refactor this later when I feel like I've got a better handle of things. All right, what's your complaint? You happy now? No? Used space character for indentation instead of tab, as used before in the file. Ugh. Okay, can I do... Was it shift tab? Cool, and then tab. Variable center X has no static typing. I believe these are all integers, so they should be all integers. I'm not going to use angle. Let's just take that out for now. And then we've got X and Y. Now this is division. I think it might have a problem here. Like when you do integer division in Godot, this may cause a problem. Like I think technically I need to do cast it to an int just to be safe. All right, so then we have 0. The maximum between 0 and the minimum between width minus padding. Okay. And then we have our cropped image. We do a blit rect. Cool. Let's clean that up. And yeah. And then we should be able to test. We're just about there. Cool. So I should be able to do... why not? Let's do what the AI said. There's only ever going to be 2 of these, but for debugging and testing purposes, it's useful to do this. Yeah, let's do our template frame. Let's check that first. Box. What did you do? Oh yeah, boxes. Boxes that. That's going to be a dictionary. And this is an image. And then what I'm finally going to do for I is an int. And then let's do our emit. And for this, we're going to give I plus 1. Because the first one's going to be 0. So then we'll have 1, 2. That's what we should have. and it'll be our cropped image. And that's it. This one, I'll give you a value of 5. We'll be missing 4, but just in case, on the off chance that this overflows, like it's not 2, if there's a coding bug, and it returns 3 or something. Actually, let's prepare for that eventuality. Make that 10. So then we should see image 0, image 1, 2, and then 10 is what we should see. All right. Oh, it wants call deferred. Right. Okay, I did the wrong thing. I forgot that because this is running in a thread, I can't just call the, I just can't emit the signal directly. I have to call it this way. I have to call deferred on it, so that way it happens asynchronously. I don't fully understand. It's one of those things I've been looking to dig in a little bit deeper to understand, but I have not. All I know is because we're in a thread, we can't just call. We can't emit the signal directly. That's why I left this commented out here as a little reference to that. All right, so we'll log the initial one. Then we will, our template frame will log it. And then we'll log out our cropped images. Hopefully this works on the first try. If it does, then I'll move on to maybe like doing a quick test with this then. Yeah, let's just not touch this yet. And let's make sure make sure this is still functioning as expected from last time. We'll go with done cropping images. Call done logging. Well, let's just do start cropping images. Let's do it that way. Excuse me. And then for this, just to be slightly clean, we'll do start statements instead of done statements. Start merging frames. So that way I can just see like how long does this step take, how long does that step take. All right, let's hook up the VR headset and give this a run. Where's the quest? Let's start our casting. And yeah, we have our book. Let's build. Let's get this up. 1, 2, 3, 3. And that up. And take a sip of water. This is exciting. I feel like I'm actually making real progress now, as before, where I was kind of just sitting and stewing and making progress on learning a lot about things like OpenCV and how to solve the problems I'm trying to solve, but not actually solving anything. Hopefully now that's all changing. Yeah. Yeah. This first build will, of course, take time, as always. The first build of the day always seems to. Let's see here. Okay. I'm sure there'll be some small bug that I neglected. Or maybe not. Sometimes things just work on the first try. We'll need a controller. All right, let's get the headset on. Okay, and then launch the app. Okay, and then let's see how that does. Oh, and we crashed the app. That'll happen. And why did we crash the app? Did I get anything off of it? Hold on. Out of range. Okay. So we captured 3 frames, start cropping image, and then we chose to write a file. That seems to be a thing. Although that is probably this one up here. But still, let's go take a look. And might as well uninstall. So what did we end up with? Today is the 23rd. 2 images, and we got 0. Image 0. Which isn't an image that's not going to tell us anything. Other than the quality was kind of meh, as expected. Alright, so crashed. Let's try again. Hold on here. All right, that's fine. Yeah, so I should be able to just launch it again. It'll go fast. I guess technically, no, I uninstalled it, so yeah. If I didn't uninstall, I wouldn't have to do that. This time, I'll do permissions, and then I'll turn on logging, so we can actually get error log. And then, yeah, I'm sure there's going to be something in the C++ code that does not work. All right, there's the permissions. Cool. Now, oh, well, I can't do the logs yet. Right, I gotta get the headset running and then I can do logs. Because we don't have a process ID yet. Now we have a process ID. And since we couldn't see it before, might as well do the tail here. And then that way, you can maybe see the error before I see it, since clearly it's not going to be as visible. Okay. And crash. There we are. Cool. Well, that was not fun. Let's see here. Control C. Let's go look at it. Where's our error log? It crashed, so we should have something right here at the bottom. Okay, Godot. Fine, be that way. Okay, there we go. So, fatal signal 6. Terminating due to uncaught exception of type exception in OpenCV. Assertion failed. M-type equal type 0. In function create. Error. Assertion failed. Okay, well, start cropping images. Requested object was not found. I've gotten this error before. Briefly tried to fix it and it doesn't seem to matter, so whatever. Yeah, it's looking for something in VC package, which is like cool. Why? This is an FPS log, so really it's this right here. Or is this the same error as above? File. Oh, interesting. So it's complaining, it's saying this is the path. But maybe it's not. Maybe this is, like, it's logging that, this is just saying, hey, here's the path where the error occurred. Okay, so maybe the error actually, for this one from before, object not found, could not open directory. And then ignore the path being weird. Could not open directory. So it's looking for that directory. Base APK lib. Huh, okay, so something is trying to access a folder. And it's this glob.cpp file. This is, for whatever reason, saying, hey, go to the file system and open a folder. And it just can't. We wrote a file. Yeah, we get this error. Okay, so the error still kind of means nothing to me. It just means something in OpenCV, for whatever reason, wants to try to read a file, and it can't find that file, so it's throwing an error. But it doesn't seem to be something that I need. Now down here, this is the actual error I do care about. So the error is really just assertion failed. Okay, I need to add log statements at a minimum. That'll also tell me how performance is going. But let's see how far we get before we hit a wall. Oh, and oh, by the way, it's possible I'm missing an import. Did I forget an import? I could just throw that error to AI, but I don't really want to. I need to debug this code anyway, so I understand what the code's doing, so I can fix other things. So let me see here. So it said we needed a bind method. Here's all the C++, the CPP code, the .h. Features 2D, let's see here. Okay, so it's saying those are needed in the .h. Or was it the .cpp? All right, so it's possible. No, it's saying put these in the CPP. So one of these is OpenCV. CVEFG, HIJK, element OP. Yeah, we have image proc here twice. This is dumb. And then Godot. We've got some Godot things. Also this. Yeah, let's do a little bit of cleanup. Godot CPP array and dictionary. I wonder, there could be a namespace issue, because if it's like a Godot dictionary, but if we're in the CV namespace, it might try to use like a dictionary from there, maybe. And then where's our logger? Right. So let's add our log statements. And we'll start high level. And the best way to use loggers is to use them in place of code comments. Why code comment when you can do a log statement? Oh, but the performance is worse. Okay, maybe, but you know, it's like chances are, if you're leaving a code comment, oftentimes that code comment could be replaced by either a better method name, just improve the naming of variables and methods that you have based on your code comment. Or if the code comment is still needed, there's a decent chance it would be better as a log statement. And if you really care that much about logs eating up whatever memory or something stupid, you could add some sort of catch that says, cool, like, again, I have this logger method. I could add a check that just says, hey, if we're in production mode, just don't bother. Easy enough, right? Okay, let's rebuild. Can always rip them out later too. This is also going to help me understand the performance implications of this method, because each of these log statements is going to have a nice date timestamp on it. So I'll be able to see how long will be spent in each step of this detecting bounding boxes. Let's exit out of this. I may have actually, just by doing that import, may have fixed whatever the issue was, since I forgot to do that. We'll do our uninstall. Build succeed. Okay, excuse me. I thought maybe there was an error there. Okay, bring that up. Bring this up. That up. Yep, we got permissions there, and then let's not tail. Tailing's not gonna show us anything at the moment, it doesn't seem. Am I out of coffee? I am. Sticking to water. All right, permissions, 1, 2, 3. There we go. Okay, and then went for my mouse instead of the controller. Okay. continue, and then while that's doing its thing, turn on the logger. There we go. Getting tangled. Okay. Hit it, and still got a crash. Okay. Now what do we got? So, we have starting to crop, which is at 4404. Detecting regions, so that's 3/100ths of a second later. What is that saying? So we've got sample regions. Okay, so detect regions, sample them, cluster, and then bounding boxes. Okay, sample. And that's like, well, okay, so detecting regions was here. So detecting regions took some time. That was like a half second to just do the detection. Cropping them down for performance takes no time. Literally, yeah, like no time. And then clustering happens. Then we get to generating bounding boxes, which is all of... That actually took a little time. So the clustering took some time. Clustering took... Was it 7 to 8 to 9 to 10, 1 to 2? Yeah, about a half second. So we got a half second there, and a half second for, hold on, here to here. Yeah, so 6/10 of a second and then 6/10 of a second. So 1.2 seconds for those two steps, which is fast, but also kind of a lot of time. I don't really want to spend that much time doing those operations. Like I want the whole OCR process altogether to ideally only take like 5 seconds. Right now I'll settle for less than 10 seconds total, but my budget is pretty tight. So 1.5 seconds on the budget is, you know, already something I care about. Not that I'm caring about performance right now, but I'm at least storing that in the back of my brain. Okay, so then we say, cool, let's go generate the bounding boxes, and then that is where we get our error. Nice. So that actually means most of the steps finished. Which means our error is probably in here. Which is, it's going to be like this kind of thing. So our error was error. Assertion failed. M-type type 0. And okay, so can I wrap this in an exception? A catch. Clusters I. What is our cluster, by the way? So our cluster regions is an array of arrays of points. All right, so let's not log that because that'll be a nightmare. And then for each region in the cluster. So a region is an array. So this is itself an array of points. Okay, so it's a list of points. If m.m0 okay, so let's do gd logger, and we can do found centroids. Let's just call it centroids. I'll probably rename that later. I don't know why the AI went with that. Plus, and then I've done this before to like convert that integer to a string. How do I do that again? It's been a minute. Maybe that was ocr.cpp. Or maybe it was this one. Casting to string. Data size, that's a size t. Maybe it's that. Let me see if I got a better example. I do not, so let's go with it. And let's go with centroids.size. String is ambiguous. Okay, fair enough. That is fairly ambiguous. Godot string. Yeah, for whatever reason, this file, it complains about things like that. I think it's because, I think it complains about it because we are in the namespace of OpenCV. And this is one of those, like, reminding myself of how C++ stuff works, where it's been a while. Whereas over here in ocr.cpp, it doesn't care. Like, I don't get those kinds of errors. Or did I? Maybe I did. No, yeah, see, I was able to do this here, and it didn't care, because it knows that that's a Godot string. Because I said that we are in... Where are we? Did I say namespace? Where's our namespace? Am I blind? No, we don't have a namespace here. I thought we did. Maybe in the .h? Yeah, using namespace Godot. Which I know also there's a thing where I could do this in the .h file here, but I couldn't do it for OpenCV because there was something we were doing in the .h file where like you just couldn't do this here. I can't remember what it was. In any case, I expect I can do this now. Like if I do that, it's going to be fine with that because it's saying, hey, you're using a string, it's a Godot string. Because we're in that namespace. I believe that's what's happening here. Now, it might be good practice anyway to, if I'm going to use something that's Godot, call it Godot. So I think technically I could rip out all these places where I have Godot, I could probably just rip them all out because it knows that we're in that namespace. Now the question is over here, we're in the OpenCV namespace. So it by default is going to, if we reference something, it's going to assume it's a CV thing, not a Godot thing. So then I have to be explicit about Godot namespaced things. Okay, that all makes sense. I wonder if I need that, because I'm already doing CV. And oh, by the way, CV as a namespace, yeah, there you go. CV as a namespace is kind of tiny, right? Like, not a big deal. So I don't mind doing CV : mat, because also, like, what is mat? It's nice to know it's a CV mat. Okay, OpenCV mat. Is that a material matrix? Okay, it's probably a okay. Matrix expressions and arithmetic. C mat expression. Okay, so it's a matrix. Yeah, so I think I'd rather be in the Godot namespace, because then for Godot stuff, then I just know, like, hey, a print is a print. It's a Godot print, right? Because I'm in that namespace. All that is to say, I need Godot here. Yeah, Godot : which, by the way, yeah, it assumed that's a Godot array. Let's be explicit about that, because I don't want it to get confused. And this is like a standard vector. So that's the standard namespace. That's going to be all like C++ things. So this is saying it's an array, a standard array of standard arrays of OpenCV points for this line here. Okay. Cool. So anyway, I added this log statement here. This will tell us if this is a fallback. Less than 3. Why would I need that code at all? I shouldn't be doing that. Ooh. Ooh, ooh, ooh. I wonder if we always end up with less than 3 centroids. Wouldn't it be less than 2? Also, would that like never happen? Also, I'm gonna have to maybe debug this, but there's a chance that like we run this and it doesn't matter what happens, we would always end up inside here. Or there's a chance that this works, and honestly, like, I don't need the fallback. This is the other thing AIs do when coding that pisses me off, is they'll add things like this that either, like, this would never get called, right? It's like, look, if we're less than 3 or whatever, maybe I want to actually just throw an error. Like, why would I want to do a fallback? I've noticed, like, Claude does a lot of fallback logic. Like, no, I don't want fallbacks. Like, if it doesn't work, fail. And, like, fail loudly, throw errors. Like, don't give me some fallback to, like, a more generic, shittier version of logic. That's what it keeps doing. So, this version of code that I tested in Python worked, and it worked well. So either that means we're always hitting this and we rarely ever jump into this case, in which case I'm just going to delete this. Or we do this, and every single time we end up with less than 3. And so then we always do this step, in which case, why even bother doing this in the first place? Because I already know we're calling get convex hulls. Like, the whole point of this is we've already done clustering. So we've got a bunch of clusters. So the clusters are going to be, for the most part, what they should be is page 1 of the book, page 2 of the book, and then any noise in the background. So we should have 2 clusters. We probably have several clusters. Well, I already have that. Hold on. Let's see, right? Yeah, let's log it. GD logger. Let's do it. We'll say we are operating on this many clusters. I'm really curious what this comes back with. Because also, I just care about the 2 largest. So, like, honestly, the only clusters that are going to matter are the ones that have text. And the ones that have text should be, by far, the biggest in the image. Every time. largest by area, I would think. So let's do this. And then we'll close that off. Let's do cluster regions dot size. Another paren. Okay, now it's happy. So when this runs, in fact, we might only ever be returning 2 here. I think I was maybe smart enough to do that. Yeah, return top 2. Sort by size, return top 2. Okay, I thought so. Let's confirm. So we should only ever have 2 here. And it should already be the 2 that we care about. So we're looping over those clusters. Also, you get it. Then we got this empty check here, but like, why would it be empty? Like, okay, fine, sure, extra error catching. Why not? So we already have, so we're getting like the first cluster. And that cluster has, so this cluster is these are all the regions in the cluster. So that, again, there should be 2 of these. This should be 2. It should always be 2, no matter what, pretty much. So then we're looking at for all the regions in that cluster. Find the center and push that point on. Centroids. So we're going to get the center for that cluster. God damn it. This is always going to be true. All points for region in cluster region. So again, we loop over. All points begin, all points end, bounding rect. God damn it. This hurts my heart. I'm pretty sure we're just always going to do this. In which case, then, GD logger. No, actually, let's do return result. And we'll do GD logger. Returning fallback centroids. And then in this instead, what I'll do is CV, the return signature, rotated rect, which I don't need a rotated rect, but okay. Result. And then for the heck of it, I will do GD logger returning centroid. Moment. Well, I mean, these are moments. Points, fine, whatever. It doesn't matter. As long as the log statement's different, I can tell the difference between the two. And for the heck of it, again, I will do CV let's call it better result, just so the names don't clash. I don't think it matters, but good turn, better result. What's it complaining about now? Expected semicolon. There we go. All right, so now we have all the log statements we need. It seems like the error's in here though. So, Godot, why are you being like that? There we go. So it does seem like assertion failed in function create. So are we doing some sort of create step here? That might be, could be here if we're doing like a creation of something from these points. Could be inside this function. I don't know, hard to say. Let's give this a whirl. If this isn't clear to me what's going on, at least I can pass it to the AI and have it maybe glean some insight for me. Because usually that is one thing that AIs are pretty darn good at, is if I give it an error, it'll say, oh yes, of course, based on the way CV moments operate with, you know, creating a 0.2f from those moments, like you're getting this error because your moment is of the wrong type or something. And you're like, okay, which if I spent 30 minutes reading the docs, I could probably figure out on my own. But the AI is really good at just knowing that off the docs. So they're really good at they're really good documentation readers. They read the docs. Okay, let's kill out of this and run it again. I did run it already, right? Fine. Let me just run it. I'm almost certain I did it. Whoa. Maybe I didn't. Well, hopefully it's fine. That was the Windows version I was building here, right? Technically it doesn't need that. It just needs the Android version. Although I guess once it's deployed and it does the remote debugging session, then it probably needs it. Yeah. I'm sure it's fine. All right, thinking. Where's our permission check? There we go, permissions, and let's queue up the logs. Okay, logs running. Is log running? Yes, log running. Cool, and trigger. Waiting for the crash, there we go. All right. Let's go look at the logs. So, huh, 215 clusters. So I'm wrong? Oops. Control Z. Here we go. Oh. No, that's how many regions we're working on. So we go through this loop twice. So I should see each of these log statements twice. One per cluster. So that's how many regions it should be. Okay, so maybe I'll forgive it. So it's saying that's how many regions there are. And if there's fewer than 3 regions in the cluster, then do a fallback, which is never going to happen. I mean, honestly, if we get fewer than 3, I just don't even want a bounding box, because I'm never going to be running this on a, like, I don't know. I say that, but you know, maybe if someone's reading a children's book, I don't want to. No, cross that bridge when we come to it. If we have, if this thing needs to handle children's books, let's cross that bridge later. So we should skip over this logic. I'm going to delete it in a second. In any case, this was almost instantaneous. So this took like no time, 0 time to run through this. And then we jumped over to the found centroids. So that took like no time. And then we crash. Okay. Let's rip all this out. So we have our centroids. Yeah. Yagni. Not going to need it. So then we create a hull. We call convex hull on it. Centroids and hull. Let's just call this result. And just for the heck of it, let's add another log just to see. Getting min area. This is also going to help me debug it with the AI, because I can drop this code to the AI. It won't get distracted by the else condition. And with all the log statements there, so I can drop it the code and I can drop it the logs, and then it'll say, oh yes, of course, exactly. Here's exactly where your problem is. Found centroids that look like. So now what I can do is centroids 0. What is this? Okay, type float. So it's a CV point. Not suitable conversion. All right, fine. I'll just delete it. It'll help to have the log statement. All right, let's run it one more time. And then I'll probably go to the AI. It does seem like once we've got the centroids, something's not happy. And most likely, the AI will know the answer immediately. Without it, I'd have to like go dig in the docs for an hour. So it's cool. This is one of those scenarios where it's definitely better to use AI tools. All right, let's bop out of this. Wait for that to finish. Come on, come on, come on. Sweet. And wait for the permission check. There we are, and queue up logs. Logs running. Okay, and trigger. Now what does it say? Found centroids that look like... Ah, that's annoying. I didn't want to say that. But we didn't do the min area. Okay, so it is this step here. So then let me go ask Claude. And I'll do this as a separate thread in case I need to jump back to this one. But let's do a new chat. I have a block of C++ code that is throwing an error in my GD extension for Godot 4.5. Can you help me figure out what is wrong? Question mark. Below is the method where the error is occurring and some logs. Cool. And well, we can grab more than that. Yeah, just make sure the spacing's good, just in case it gets confused by that. And then our logs are going to be no, let's do just minimal logs. Oops, doesn't like that because I'm on Windows and I can't do, apparently Control C doesn't work and everything. Control insert. All right. The issue is a type mismatch. The error occurs because you're mixing .2f float point coordinates and point integer coordinates. Here's what's happening. Well, you wrote the code. You create centroids as an array of floating points. Gotcha. So centroids is an array list of floating points. You pass this to convex hull. Convex hull, which wants an input array, but it doesn't say what type. Input 2D point set stored in a vector or mat. Where hull, so it just wants a vector of point, integer points. OpenCV is trying to convert between the incompatible types internally. The fix is to keep consistent types throughout. Here are two solutions. Solution 1, use float types throughout. Recommended. So, why can't I? There we go. Vector of point. Okay, so it didn't change the method signature at all. We're doing floating points. Looping over the regions, get our moments, do our comparison, get our floats. Point 2f pushed onto the centroids list, which we are already doing. And it's saying 2f. Let's stick with a floating point hull. Do I want floating point? Because I don't know. Is it mathematically faster to not do floating point? And also, since we're using this to get a bounding rectangle, well, let's first fix the issue, and then I can ask that question of the AI. And that's it. So it's just saying do that. Use integer types. Because centroids are naturally floating point values, moments divided by area. Centroids are moments divided by area. You avoid precision loss from casting to integers. Mid-area rect works well with both, but floating point gives more accurate results. Type compatibility issue. Fair enough. Again, something I would probably 30 minutes digging into the docs probably would have figured out. Okay, so I wanted 0.2f. This, for whatever reason, was set up as not a 0.2f. Again, this was coded by Claude, so Claude messed it up. And who knows, maybe it was mixing code examples from whatever code it stole from the internet. Let's just run this, make sure it works, and then I'll ask the question of, would going with floating point be slower? And also, we're talking about a bounding box to crop, which is also fine if it's off by a pixel or two. We don't need that much precision. Does that weigh on this decision? Again, I don't expect it to be that much faster. But actually, yeah, how long are we actually spending? I mean, it depends on how long we're spending in this method, right? And, you know, small decisions like this could have an impact. If it's slightly faster and uses slightly less memory, overall that could play a big part in what I'm trying to accomplish with this app. Probably not. But the only way to know what levers you can pull to improve quality and performance is if you curiously ask yourself these questions as you're coding. And then put it out of your mind and just go with what works. But then at least then later, when you are trying to debug, you're not like diving into code that's super complicated because it slowly got more complicated over time. And then you're trying to solve a hard problem like how do I improve performance on a massive chunk of code which you have no understanding of. Best to slowly get your brain to have some understanding little by little in bite-sized chunks. It'll make debugging later easier. I still contend that like AI suffers from the same problem that humans suffer from, where if you're not smart enough, like if you write code as smart as you're capable of, then you are not smart enough to fix your own bugs. And in this case, it's just a typo. But if there's a more complicated bug in this code, the AI is not going to be smart enough to fix it, which means I'm going to have to fix it, which means I need to get smarter than the AI on this code that the AI wrote. I have to act as the senior tech lead who is making sure the AI's code is solid. If I don't do that, then whatever bugs result that the AI can't fix, which I've come across them before, by the way. I've come across bugs that the AI doesn't know how to fix. And it gives me solutions, and its solutions are garbage. So who has to fix them? I have to fix them, which means I have to be smarter than the AI. It's not to say that the AI isn't capable of understanding these things. I mean, it can have PhD level knowledge, but it gets backed into a corner, and sometimes it just can't see the solution to a nuanced bug that's just sitting right in front of it. Okay, well, things didn't crash. So, in theory, that fixed things. Yeah, let's load that and let's quit that. Should have closed the file anyway. Let's get our files off. So we should actually have files now. Where are they? Where's my command? There we go. And let's take a look. What? Where are the images? All right, something else went wrong. So it didn't crash at least. But something else happened. Okay, let's also just kill it to preserve headset battery. Invalid frame call. Again, Godot, knock it off. Here we go. All right, this is all noise. It's all snow, basically. What is this? Permission denied. Yeah, that error doesn't matter. Here we go. Yeah, as expected, we saw this twice. Tiny number of regions, by the way. I was actually hoping for more than 1,000 regions, probably closer to like 2,000 or 3,000. I may have to tune things, but that's fine. So how long does it take to do the bounding boxes for both? We're talking like literally no time, 0 time. So I'm not even going to bother asking the AI what's more performant. Like, why bother? Because hell, even if I could cut the time in half, we're talking literally 1,000th of a second. I got bigger fish to fry. So that finished. And then what? Nothing. So we may have succeeded. Let's add a log statement here. Let's do gamestate.log. Have B boxes. We'll do string on bounding boxes. Is that going to even, is it even going to like that? Let's just see what we get there. At least let's see if we have bounding boxes returned. That'll tell us something. That'll also tell us like the overall performance time of just this entire call all by itself, which again should be less than 2 seconds. I think it should be about 1.5 seconds to do this whole thing. And then on the C++ side, did we saw the returning centroids. So we should have returned. There's probably no reason why this wouldn't have worked. So I doubt that there's a C++ issue. We then call deferred. Well, we then call this. Let's do gamestate.log. I'll probably change that from _log because it should be a public method. By putting the underscore here, I'm signaling to myself that I shouldn't be calling this, but it's part of gamestate, so then why? Yeah, it should be public. It should just be gamestate.log. Creating cropped image. Gamestate.log. Doing litrect. And why not? Let's do gamestate.log. Returning image. At least this way I can see, which step is failing. Visually, it seems like there's no reason why it all shouldn't work, which means maybe the step that's failing is actually just the call deferred, which on debug HUD, yeah, we should see it's a print statement, but we should still see it anyway. All right, let's run it. Let's get out of this file. Let's clear that. Yeah, I mean, I wasn't surprised to see errors in the C++ code, although I kind of expected it to fail sooner. But who knows? The day is early. Perhaps it did fail sooner. We just haven't seen the error yet because maybe it does a bounding box of 0 pixels, and heck, maybe that's why we didn't write an image, right? Maybe the bounding box is like nothing, tiny. And it failed to like write a 0 pixeled image. All right. I probably don't need it, but let's do the logging anyway. Book's ready to go. Okay, there we go. What you on about? Trying to assign an array of type array to a variable of type array dict. Huh, well, we didn't get that error last time. An array of what? Box dict. Can we do array? Didn't we do array before? This is a typed array. Yeah, it's funny. Yeah, like this it's fine with. Maybe because there's no collision. And it was fine with this too. I'll just do the typing on it for now. Again, I'm not a huge fan of, in general, typing is necessary here. I'm not a huge fan of typing just because for me, like this is less readable than if it was just typed array image. I don't really need to know that it comes from Godot. But should this actually be Godot typed array of Godot dictionary? And if we do it there, we have to do it on our bound method, our binding. Do we? No. It is in our .h. In our public method, we have to do it here. That should be happy now. Be happy. There you are. You're happy. And we will rebuild. Starting with Windows, and then we'll do Android. I could just go with simple array, but I don't want to be a simple array. Like this should be able to be properly type annotated. All right, let's see here. Cool, and then let's run it. Oops. Let's kill reading room real quick. No, that's the files. Cool. Permissions. Again, I don't think I'm going to need the logs because the issue is now on the Godot side. It's in GD script. It's not going to be in C++, our issue, most likely. All right, let's get that permission check. And then we'll get the logger set up anyway, just in case. Logger's running, and then okay, there's our book. Oh, I think it finished. I think it actually did it this time. Yeah, doing blit rect. Okay. We've got our B boxes. Cool. So I can actually see what the values are. And yeah, looks like they are floats. Maybe I don't want them to be floats. 1, 2. Oh, right. Okay, well, it's doing OCR. Let's keep with the logs anyway, just in case. Let's wait till Hawker comes back. Not that it matters. Great, and we got our results. Let's get our files off. And let's kill it. And let's see what it looks like. This should actually be what we want now. There we go. Yeah. And I can already tell it succeeded. So we'll go through this slowly just for the heck of it. There's our original image. Here is the template one that we used, but they should be basically identical. The only difference is this one was probably taken a few frames before this one, so they're slightly different, but this is the one that we used. Let me just see here. I mean, that's actually fairly readable whenever anything is left out from the set, this set. Yeah, so boom. Okay, the code works. So I don't have any bugs to fix in C++. Yes. Awesome. So I can do some cleanup, you know, see if there's any other like sub steps within the C++ code that are just unnecessary. You know, maybe get rid of the floating points and let's just do integers anyway instead. But on the face of it, this is working. Now you'll notice page 1 and page 2 are in the wrong order. So I do have to fix that. This should be the one that we care about first. This is the one we should be trying to OCR. And then this is merging of multiple images together. I want to go deep on this for a second. It did make some things crisper, but you know, it does the merging of multiple images. I don't know. We can kind of see on the corners here. I think there's, when it does that merging, like the frames are off ever so slightly. Actually, you can see right here vertically that the left at the edge of the book, we can almost see like some shadowing happening here. And that tells me that the image merging is off ever so slightly. Like actually, I think it probably did a fantastic job right here. This looks like it's perfect, but everything else is ever so slightly off. And so what we end up with is, this is probably a success. This is probably successfully merging the images and we're getting cleaner, crisper words here. Whereas up here, not so much. This is probably garbage. So now my question is, if I run this operation after, so let's grab this, crop all of the images. Let's go crop all the images we have to this, and then merge the crops. Do we end up with like a better, do we end up with a better blurring? That's the question. Before we dive into that, let me take a quick breather for 1 second. Get my bearings. Take a sip of water. Let's look at these logs. Again, I'm mostly just curious, like how long things took. Oh, that's cool. I didn't know you could do that. Collapse duplicate messages into one. Ah, okay. Copy selection. Okay, I think what I wanted was this button. There we go. So here we are. So we're starting on the operation. Capture frame. So we wrote an initial files just somewhere. All that's within, this is 38. This says 1 second later, but this is probably like a quarter of a second or something. really what we want to say is, let's just call it 38. 2 seconds later, we have our B boxes. So it did take less than 2 seconds. And then to crop, even to crop. Creating cropped image. Right. Oh, okay, right. Because it's a called delay to write the file, this line down here, writing file 2, actually occurred up here, but these log statements are getting blended because things are happening asynchronously. So returning image. So really this is our stopping point. So starting merging frames, so it's 40. So it literally took 2 seconds to get our cropped images. Under 2 seconds. Well, up to 2.5 seconds, maybe. But even then, look, right, now we're going to start on merging frames. We're still in 40 here. Aligning frame 0, 0. So, yeah, it probably took under 2 seconds to get our cropped images. And then aligning the frames, that always seems to take a couple seconds. Averaging, enhancing. Yeah, so then the aligning frame 1, that took 10 seconds or so. Right, so now we're getting into slowness. But again, this is on the whole image. So this, I already knew before that this was slow. Once I switch the code over to doing just on the cropped section, I wonder how much faster this gets. And then we call OCR. Oh, by the way, OCR, no. Let's not call it that. That's a terrible idea. OpenCV. That's what it is. That's what this logger is. And then we call OpenCV. And then, you know, we have our results. And it got a score of 0.26, which, again, means nothing. But visually it looks terrible, which I kind of expect. So we're not in the realm yet where I care about its actual score. But this is OpenCV at this point. So I think, yeah, this is the done. So what is it? 5512. And when did we start? 54:38. So 20 seconds, 30 seconds, 34 seconds. 35 seconds. So over 30 seconds. That's the time to beat, which I think we can do quite easily. So if we'll still do this. We'll still do the bounding boxes for both. Who cares? Let's fix our log statement there. I lost where it was. No, we should be up here, right? Yeah, we got our bounding boxes. Right. So let's do, okay, let's do var cropped frames. is going to be an array of image. And we're going to do for frame of image in frame buffer. Cropped frames dot append. We'll call crop image from bbox, and we will do frame it's called bbox. And what we'll do is little hacky, it's fine. Var bbox is a dictionary. And then we'll do why not? We'll just do bbox here. And it should be, you know, since there's only going to be 2 in here, the second time through is actually the first page, and that's the page we care about now. Right now we're debugging, so who cares? But the point is, it'll just be one of the bboxes, but it should be page 1, based on my understanding of this right now. So then we'll have the bounding box for page 1. Then we're going to go through our frame buffer, which is going to be 3 frames. Yes. So we should have 3 frames, which actually means that image is even worse from one before, because I'm pretty sure we saw 3 shadows. So it was definitely blurred off. Anyway, so there'll be 3 frames. We're going to go crop each of them. Crop from bbox is this little function down here, which is, this should be super fast. I am actually curious how quickly we do this. And the best way to do that would be, let's just do GameState.log cropping all frames, right? And then down here, let me just get rid of these, because I know these work, right? I already know this logic works. So I don't really care how fast this is. I don't think I could speed it up anyway, but even if I could, I just care about how long it takes us total to crop 3 images, which I'm guessing is 1/10 of a second. Nothing to really worry about. But these log statements will at least tell me that, like how long did we spend here. Of course, obviously, this is going to be second time, because I can't do milliseconds for some reason, or at least not without a lot of work, but that's fine. As long as it's less than a second, I don't care for now. And then we're going to pass this in. We're going to go crop. You pass the crop frames to this. So this, in theory, then should take us from 35 seconds down to nothing. Like this should, not nothing, but we should be under 10 seconds, would be my expectation. Because it should be a quarter of the time. Yeah, so let's give it a test. And I actually hope, feeling pretty good about, hey, we may actually get like higher quality. I'm going to be annoyed if it's worse. I want to be cautiously optimistic. I want to believe that we'll actually get better merged images from this. If it's worse, I think it just means like the merging of the image logic needs some tuning to improve its ability, which I could go deep on. Also, then like dewarp deskew could help too. So in theory, if we did dewarp deskew, again, I would do the same approach of let's compute what the dewarp and deskew would be for a single image, and then apply cropping and dewarp deskew to all the images in a batch, and then go merge them, right? And in theory, that would be, yeah, that would be best performance quality. I don't know. Yeah, let's do logs. Why not? All right, let's check it out. Let's see how we're doing. We already got a result. Wow, the OCR was terrible. That doesn't bode well for us. That tells us that things did not go well. Let's grab the files, take a look. So that was a pretty bad bounding box. I don't know why it had trouble that time. Maybe because of how I was holding the book. It shouldn't have struggled that badly. It's possible the noise from back here messed things up. Oh. Somehow it decided that that was our... But it looks like it didn't improve, because look here. Okay, that's fine. Let's run it again. That's tuning I need to do in the bounding box logic. So that'd be an interesting test case to export out and go debug in my debug logic on the, which is in Python with OpenCV, to see like what was the scenario there. Why did it identify the monitor? Probably because the monitor had more regions detected in it than the book. That's fine. For version 1.0 of this app, I'm not going to care about that. At least not if I can help it. Okay, let's see how it does this time. And this time I'll look down, that way the monitor isn't in the view. Oops, actually, did I forget to... I did. Let's start the logger. Okay, and then let's look down a little bit so there's not much for it to detect, and then there we go. And well, it is faster. Now we're OCRing, and it's actually taking a moment to OCR, which means there's something to actually OCR. Yeah, I mean, it got something. It's ugly, but let's do it. Let's take a look. There we go, and that would be page 1. Looking pretty good. I'm going to keep this around over here. There was page 2. Ooh, page 2's not good. Interesting. Hold on. Let me go take a look at this. Oh. One of them was a page, and then the second one was computer screen. Computer screen was what we did. Okay, so the order gets flipped somehow. I end up like doing the wrong thing. So in this case, page 1 is correct. The one that we set as 1 is the correct one. Page 2 is the one that we, for whatever reason, detected poorly. And that is the one we tried to merge. Now the question I have is the quality on this better? Or are we detecting artifacts? Actually, let's go there. If I look over here, I do see 3 lines. There's still 3 lines there. And in fact, this top line is quite bold. So I'm actually going to say that it succeeded at merging them. I mean, look here. This is a little fuzzy. So I think actually it worked. I actually think it did a good job. So maybe... Here. Let's go look at the top of this paragraph. Yeah, I think it did a good job. So I'm going to go ahead and assume that maybe the issue is that it the frames are too close together, maybe? Like, what happens if I spread the frames? Do we end up with better data and therefore a better enhancement? So that's a successful test. I do think interesting that we go through. Let's do var box equals dictionary. Let's go with box here. And then we'll do bbox equals, darn it. Let's go bboxes. Why not? Let's make it an array of dictionary. Bboxes dot append box. And then here we'll just do bboxes 0. This way I can just like quickly toggle this to whichever one that I want it to be. So that should make for a slightly better test. And then enhance text from frames, but that's the frames. Let's try. I mean, let's get stupid, right? Let's go 5. That's a ½ second. That's a ½ second wait, which means we should be grabbing an image every just over a ½ second. And since we're grabbing 3 of them, that means it should take like a 1.5 seconds maybe up to 2 seconds, probably not, to grab, yeah, it'll be just over 1.5 seconds to grab 3 images. And then let's see how bad they are, right? Let's see how far off they are. Just based on how much my hand drifts in that time. I didn't have any changes over here, right? No, but we should have the OpenCV log. By the way, yeah, what was the speed? We should have seen a lot better speed, right? So our speed now was, I mean, again, it should be even faster because that crop job was terrible. We got like half the page. So we should have like cropped like an eighth, should be like 1/8 of the time. Let's see here. So we're starting on the merge. Why is it highlighting down there too? That's weird. So 49. And then we have our B boxes. Here we are, done with merge multiple frames. So 1453. So 4 seconds? Yeah, 4 seconds. That means like this time it probably will take like 8 seconds is my guess. But that means we're under 10 seconds. And then if you throw an OCR, like OCR took sorry, 13 plus 6, 18 seconds. So it took 18 seconds to do OCR. Still not great. That is not good. I thought that would have sped up. Although I do know it's going to do binarization in there, and we don't need Tesseract to do its own binarization since we're doing it for it. So there are some things I can boost speed there wise. But anyway, let's take a look. So total, we're still at like 30 seconds to do. Is that true? 1449. Wait. It's 11 plus 13. Right? 11 plus 13. 24 seconds. So we're under 30 seconds right now. It's probably worse though. Once we process a proper image. But that's fine. Again, I'm pretty sure I can squeeze out more time. So I'm feeling good about that. Hey, at least it's not over a minute, which is what it was before. I guess that was expected, right? Because before it was taking over a minute for some of these operations to run. So now that we're operating on like a less than a quarter of the image, we should be down below 30 seconds. I'm having fun, so the stream, I guess the more fun I'm having, the longer the stream's going to take, right? But I should stop soon to eat lunch. But as long as I feel like I'm moments away from the next exciting thing happening, I'm obviously going to want to keep going. Although I probably will be at a good stopping point in a few minutes, because I'll be able to see. Here, again, let's make sure we're taking up most of the frame here, and then punch. I also wonder, like, is the keyboard or something confusing it for those bounding boxes? We're aligning the frames, which is still taking kind of long. I was hoping that would have been faster. I mean, it probably is faster. Hawker itself is probably slower. What is this? I think it messed up. All right, I'm not gonna kill it. I'm gonna just get the files and take a look. Something's not behaving the way it should. No. All right, we're getting the wrong page, but that's fine. Wait, what? Why is it doing this? Why is it struggling to get full pages now when it was working, seemed to be working fine before? Again, maybe it's the background. Maybe there's something, if I push my keyboard away or if I make sure this isn't here, maybe, like I thought I had made it pretty resilient to these things. I guess all the images I was testing didn't have clear text in the background. It had room in the background and some parts of the room were being picked up as text, being detected as text, but it was fairly trivial to filter them out. Now it's like struggling to do that. Interesting. In any case, okay, that's fine. So that's what happens when it's like a whole like second and a half to capture all the images. It's so bad, in fact, you can see that there's like overlap here. I wonder what would happen if we just blindly told it to merge them. And oh, by the way, like, is there like a certain section that it merges well? Like here it's way off. Yeah, I don't think so. Okay, so that was bad. So that tells us something, right? That tells us, and that explains why like the OCR was just atrocious. Right, hold on. Yeah, because it was the actual page that it tried to OCR. So half second, not good. Let's go down to 1/10 of a second. So now, instead of it taking a second and a half to grab 3 images, which, you know, a lot of things could happen in a second and a half. The hand can move quite a bit. But if we're down to a 1/10 of a second, I mean, now we're talking like total a third of a second. Maybe half a second total. So like half a second total to grab 3 images. Probably fine there, right? It's probably good. There's not gonna be a lot of hand motion in that time. All right, let's kill this. 1, 2, 3. Yeah, I think I'll turn a couple knobs right now and see how the quality is. I may even pump the frame buffer up to 5 to see if that improves quality, or maybe even 7. Now that I know it's not going to take 2 minutes to run, I may jack it back up to 7 to see how much faster that is. And then I'll probably call it for today. I don't need the logs. I'm not going to get an error. Not an error that is going to crash anything anyway. And if I do, then I'll go back to the logs. Let me close the keyboard and let me look down here so that way I don't have to worry about extra artifacts, and we should get cleaner images this time, just for the heck of it. All right, headset off. Yeah, it's already getting Hawker results. Wow, really? That's fast, actually. And then OCR is still taking a while. And we'll uninstall. And how did we do this time? So again, something's up. Something, I don't know what it is, but for whatever reason, it's weird. Like the first test we did today of the C++ code. Oh, shoot. Ho-ho! I did not apply all the code changes. Well, darn. I have to go do that, don't I? That's fine. It just improves bounding boxes. So I fixed some bugs in bounding boxes. And I didn't apply those code changes. Because they weren't part of the C++ config. Anyway, this is the image we're getting. And now, when we tighten it up, oh yeah. That looks good, yo. I'm sorry, but that's exciting to me. Let's look at the bottom. That looks like a he to me, but it's B. Truly, I know that's like sales driven is what it is. But like, seriously. That's better. So I'm going to go ahead and say that if we go down to like 0.33, it's too fast and we don't get enough differentiation. Like even up here, like this is good. What word is that? There's a Q in there, I think. Consequences of being. That's OCRable. Oh yeah. They're buying. Look at the word buying here. Oh yeah. This works. Wow, this works. That's exciting. Okay. You know what? I'm not going to go up to 5. I'm going to keep it here. Let's go to 0.8. Let's just tighten it up a little bit just to see if that, like, you know, I think most likely we should wait between 0.05 seconds and 0.2 seconds. I'm going to guess we're probably in that range. Because a half second's way too long. We tried 0.1, and that was pretty good. 0.2 is probably similar, although 0.2 we probably would start observing drift. 0.033 seemed to not add any benefit. It's possible the frames are too close together and that the data from them is like identical, and therefore when you merge them, there's no real benefit there. Or it's possible that this is such a small timeout that we end up accidentally getting like the same frame 3 times, or like 2 of the frames are the same frame, or maybe there's something. Who knows? Who knows what Godot is doing at this level? It's saying it's 30 hertz, but maybe it is 30 hertz. But when we do the capture frame too quickly, that somehow it's getting a duplicate frame, even though enough time should have passed to get us a different frame. Or again, if we get 2 adjacent frames, their data may be too similar, and we need data that's slightly different from each other. So I'm going to go ahead and say that we're probably should be between this range. Somewhere in that range is probably good. Let's take a moment. And where is my code? Probably somewhere here. No. Hold on, let me go. Yes, I know. Okay, let me go grab the code. Hold on. Let me see here. This is the optimized to work well for several scenarios. So this is the code change I need. So let's go find kernel size. What? No, I don't want to pass. Right. What is that kernel size? Is an integer? Yeah, okay, fine. Let's do int let's bring that in. Where is this being called from? What? Are we not? I'm confused. I thought. Oh, we are calling this from Godot? Really? Are we not calling it at all? I am quite confused. I think this is the wrong... I think it's the wrong morph. I think that's actually a dead method that I was not calling at all. All right, let's go down. Yeah, see, there's all these morphological steps that need to be deleted. Cluster regions morphologically. Kernel size. Here we are. Okay. I need 2 of them. I need, was it kernel width and kernel height. And one of them is going to be divided by 50. The other one is going to be divided by 15. So we treat horizontal and vertical differently. So that helps to solve with page separation and other kind of issues. Yep, so that's it. Just using special width and special height. Detect, so. Yep, detect regions. Here we go. And then we have what? Min area. should be 5. Max area is 100 is the new setting. And I think I already have this. I already have it, but there's a code change to it. I think that is what it is. Right. So we should do if, what is it? Regions dot size is less than or equal to, I don't know if we can even do this in C++, target regions. This'll actually, this is the thing that's going to fix a lot of stuff. Return regions. Yeah, can't do this. It's that, right? Happy now? Right. Let's do less than equal to. Yeah. For okay, so that should be a valid. Well, yeah, actually, here's an if check down here. Yeah, all the syntax is correct. Regions.size should be the length of the array. Okay, I think that was it. And then the rest of this is yeah, the rest of that's fine. And we already were doing grid sampled regions. Yeah. Okay. So that should just fix the bounding box issues. We should actually, now we may, even with computer monitor in the background or a keyboard in the background, we should properly be detecting page 1 and page 2. It should be filtering those out. We should be doing a better job. It should more reliably find those 2 pages. Now, again, that was a scenario I didn't test with having like clear text in the background, but I think it should still work. And then again, we tune this slightly better. I wonder now. Yeah, it still didn't OCR very well, but that's okay. I think I know what I can do, because I haven't even done improved binarization. Like, so the next step would be, can I take that image and do better binarization on it? And I know how to do improved binarization. I think I already did Windows, but let's run it again. All right, so this will be the last thing I'd run, and then I'll call it. See, it didn't do Windows. It shouldn't be compiling unless there was a change, right? So also, it seems like it's going a little slower today for some reason on the builds. Weird. That is odd. It should not be compiling unless there's a code change. Huh. That's new. It didn't do that before. Usually that's like the indicator as to whether or not you already built it, is if it builds and it doesn't give you those lines. All right. Permissions set up. Let's go. I'm actually super excited. Like, it's super cool to see that actually work, the merging of the images. And the fact that, I mean, I could probably make it faster, sure. I'm feeling really confident now. And I'm feeling like I'm like a day or so away from maybe, just maybe, this being ready for me to move on. Like basically my goal for this morning, right? But not as close to the goal as I would have hoped, but you know, things always take longer than you expect. But I do think I'm super close. I'm like knocking on the door. I'm like a couple of small optimizations away from this just working. All right, let's go. In fact, I'm probably 1 or 2 optimizations away from switching to, hey, we actually need to just care about speed now. It's not about quality anymore. Let's switch to focusing on getting it reasonably fast, 10 seconds. Okay. In fact, I'm going to intentionally leave noise in the background. Let's see how it does. It should, ideally, still find just the 2 pages. All right, we're aligning the frames. What's our total time? Ooh, failed to get results. 600, yeah, that's not what we want to see. Again, it should be like 2,000. Did it not save? What? 1246. I have no 1246. What's going on here? Oh. Yeah, well, that'll be your problem if you don't pull the files off. Okay, so that did well. What it did though is it saw this and thought it was part of that, and it saw some character down here and tied it in with that, because I think I'm being more permissive vertically because of paragraph separations. So if there's a paragraph separation, one of the problems I was having is it would detect the top of the page as the page, and then the bottom half it would skip because there was a not paragraph separate. It was like you'd have like a bigger separator here in the middle. And so I made it so it was more flexible vertically, but that means now we're gonna get some garbage. Page 2 though, it didn't clump those in. So page 2 it treated as its own page. Now why is it picking up this over here? That really shouldn't be, but okay. And then this is what it OCR'd. Let's go deep on this. Yeah, not great. But how is the quality of the merge? I'm gonna say not great because we have like a weird border over here and a weird border over there. So let's run it again. And this time, let's close the keyboard. And let's not have the monitor in the way. And now let's run it. And we will do a performance checkpoint here. So 49.26. Got a bunch of text this time. 49.26 to 49. So 26, 36, 46, 23 seconds. 23 seconds. I'll take it. I think I can easily cut that in half. Okay. And then what do we end up with? Yeah, much cleaner this time. So again, that scenario of text in the background, I'll have to test that scenario at some point. I might ignore it for now. Ooh, it shouldn't be getting that much up there. It should be a bit of a tighter grab. Well, let's see how it did. Oh, well, it did. Okay, so that's a problem. It keeps flipping which one is which. I need to have it return the bounding boxes in order of which one is furthest to the left. I think that I should do that on the C++ side. I think that's the most reliable thing to do. But how did it do? I think there's a little bit. Yeah, I think we've got a little bit of a loss here. But overall, I think that's pretty good. And I was kind of holding the book a little further away. So one good indicator, one way to like really test this would be to take this up to like 7. Okay, this is the last thing I'm gonna do, and then I'm getting hungry, so let me go deal with that. But if there's any drift, then like this is where we will really see it. Although actually it's supposed to like average between them, so in theory taking 7 may improve the quality, maybe, but it's drastically going to increase the time. So I imagine we're going to go from 23 seconds to like 45 seconds. I don't know if that's something we can do in parallel. It might be. I might be able to refactor that method to like call it multiple times and have them run in parallel. I don't know. Because that would cut down on the time if that was the case. Okay. So now it's going to align those frames. It's going to take a while. I believe I am doing the middle frame for the alignment, but that's something I could triple check, make sure it is grabbing the correct frame. That was faster than I thought it would be. Well, it was pretty fast, actually. I didn't think it would be that fast. Looks like it got some bleed over between the 2 pages. Let's see. Why? Okay, yeah, there's something funky going on here. It didn't grab the tops. Huh. There's okay. Darn it. There's something with the bounding boxes I gotta fix. But holy cow, is that good OCR content right there. You can see we're at a pretty harsh angle here, which Tesseract's not going to like that. So this is where dewarp and deskew would come in and help. Also, again, our bounding box is trash. If we had a better bounding box and we dewarp deskew, then we would end up with like flat horizontal text that would, and the data's been merged really well, actually. Okay, so I think going with 7 was the right call. That is quite readable, actually. If I can read it, Tesseract can read it. We do have some like pretty bad garbage down here. And then when I do dewarp or deskew, that is the one question of do you... my hope would be you compute it on one image, and then we do the same dewarp deskew on all of the images in bulk, instead of having it compute it per image, then merge them, and then we should see some good alignment. I would like to err on the side of this being smaller. I guess that'll be a balance between making this number smaller and making this number smaller. Because we could end up in a situation where making this number smaller worsens the quality, which makes us want to make this number bigger. But if this number is bigger, there could be an inverse relationship here. If I up this number, make it bigger, then maybe we don't need 7, we only need 5 images, right? I don't know. You know. Yeah. Yeah, it all depends on how much it impacts things. And then what was the time on it? Probably delete some of these logs so I can see this more easily. 53:17. So 17 to 56. So 30, 40, 50, 36, 39 seconds. 39 seconds in total. But we're talking 17 to 28, 38. Again, like 25 seconds. Okay. That's a lot faster than where we were before. Okay. All right, well, anyway, I got a lot to think about. I think that's where we'll stop it here, though. This was fun. Thank you for hanging out with me. And yeah, I think one way or another, I'm going to have a good, interesting OpenCV devlog or like YouTube video to put out. So I'll probably put that out. Hopefully later this week. Who knows? Maybe if I solve some of these issues I'm seeing and I get the quality up and I get it to the point where it's like OCRing half decently, then I think I'll probably put that video together. But anyway, thank you for hanging out.